Good morning, students. Today, 15th March, 15th May, 12th English medium. Chapter is current electricity. Yes. In last lecture, we have discussed about Kirchhoff's first rule. What is Kirchhoff's first rule? That current leaving any junction is equal to current entering any junction. Okay. Sum of current entering any junction is equal to sum of current leaving any junction. Okay, yes, it is very simple law. Now second law is Kirchhoff's second rule. It is also called loop rule. It is also called KVL. But before that, see, here we have one chemical cell. It is a positive terminal, it is negative terminal. Okay, now when current is flowing, okay, see, it is positive terminal, it is negative terminal. If I want to bring a unique positive charge from this negative electrode to positive electrode, then yes, it will not move by itself due to repulsive force. So yes, when you need positive charge move from negative terminal towards positive terminal, we have to do some work, and that work is stored as its energy. Okay, and yes, this work is nothing but chemical process between this material, okay, between styles. So yes, when unique positive charge moves from negative terminal to positive terminal of cell, we have to do some work. That work is done by chemical forces, and yes, that work is stored as its energy, and this energy per unit charge is called EMF. So it is another definition of EMF. Okay, when unit positive charge moves from negative terminal to positive terminal, that energy stored per unit positive charge is called EMF of cell. When current is not flowing, when current flows, then yes, then due to internal resistance, some of the energy is used, and it is called terminal voltage. So what you have to remember, when we move from negative terminal to positive terminal, yes or no? Potential increases by E. Because potential is nothing but energy per unit charge. So you have to remember this concept. Now, in network, we will have to face cells, resistors, capacitors, etc. Right now we are taking only two elements, resistors and cells. First of all, cell. See, first of all, it is cell. Let it is cell. Okay, having EMF E. Okay, it is another situation. Its EMF is also E. Okay, now, if in a network we consider any loop, and if we are following that loop, means we are moving on that loop. Okay, it is a cell having EMF E. If we are moving, our loop is such that we are moving in this direction. It is our path. We are taking loop in this direction. Then remember, in a loop, whenever you move from negative terminal to positive terminal, here as we have discussed, its potential increases by E. So how to remember in short? When you move from battery from negative terminal to positive terminal, its EMF is plus E. Similarly, if it is positive terminal, it is negative terminal, its EMF is E. If you are moving in such direction that from battery you have to move from positive terminal to negative terminal, then yes, positive terminal to negative terminal, polarity is changed, means you have to consider EMF minus. So simply, how to remember? When from a cell you move from negative terminal to positive terminal, take EMF positive. If you are moving from positive terminal to negative terminal, take EMF negative. Clear about this? Now about resistors. See, if I have one resistor like this, its resistance is R. Current flowing from this is I. Okay, and look that we have selected, if it is like this, means in this direction, it is our path. See, this dotted line indicates our path. Okay, we are following this loop. This dotted line indicates our path, that we are moving on this loop. So if we are moving in this direction and we face any resistance R, current flowing from it is I. Okay, means we are moving in direction of current. We are moving in direction of current. We are moving in direction of current. We know that current flows from higher potential to lower potential. So if it is point A and it is point B, then yes, VA is greater than VB. Point A having higher potential than point B. So yes, it is clear, as we move from A to B in direction of current, potential decreases, means there is a potential drop in direction of current. Potential drop in direction of current. Resistance R, current I. So what is potential drop? Potential drop. Potential drop. Potential drop is here, is minus IR. Why minus? Potential drop, potential decreases. Clear about this? If I am taking another case like this, if it is resistor R, current is flowing in this direction I, and our path, our loop we have considered in this direction. So see, we are moving in opposite direction of current. Current flows from higher potential to lower potential. So obviously this point having lower potential, in this point having higher potential. So yes, when we move in opposite direction of current, potential rises. Potential rises. So yes, here potential, rise of potential, rise of potential. It is plus IR. It is plus IR. So how to remember? If you are moving in direction of current, then across resistor, potential drop is minus IR. When you are moving in opposite direction of current, then there is rise of potential, you have to write plus IR. So these four things you have to remember. From cell, negative terminal to positive terminal, take EMF positive. From cell, if we are moving from positive terminal to negative terminal, take EMF negative. From resistor, if we are moving in the direction of current, take potential difference minus. From resistor, if we are moving in opposite direction of current, potential difference positive. Clear about this? Clear about this? Now we will consider one network and then we will apply these laws. Then we will apply these laws. See, first of all, I will draw one network. For example, yes, here it is one network. Here it is one network like this. Okay, in this network, yes, you can take numbers of resistors, numbers of cells, numbers of resistors, and numbers of cells. Okay. Yes, here it is one network, one complex network. Okay, like it is point A, it is junction A, it is junction B, C, here is D, here is E. Okay, clear about this? Its EMF is E1, its resistance is R1, its EMF E2, resistance R2, resistance R3, EMF E3, resistance R4, EMF E4, resistance R5. Clear about this? Currents, let currents are also given. Let current flowing from this is in this direction. Let here it is. Let here it is I. Let here it is I. Okay, here it is like this. Current is flowing in this direction. Current is flowing in this direction. Let here it is I. Let here it is I. Correct? Okay. Now, see, here it is R3. That current flowing from this is in this direction. It is in this direction. It is I3. Okay, here it is in this direction. It is I4. Clear about random directions. Okay, no selected direction. Okay, random direction. That current flowing from it is in this direction. It is left. It is in this direction. It is I4. Random directions. Okay, random direction. So yes, here we have one complex. having 4 cells, 5 resistors, then how to solve this? How to solve this? Yes, you have to apply Kirchhoff's rule. Yes, what is potential? Potential is energy per unit charge. Means it is one type of energy. What is EMF? It is also one type of energy. And yes, energy at a point remains constant. We have to use this concept. We have to use this concept. Okay. For example, if I am taking potential at point A, I am moving on any loop, any loop, any loop, any loop, and when I comes back to point A, potential will be same. Means changes in potential as we come to the same point will be same. Clear about this? So yes, basically we can see this law of this Kirchhoff's second law. It is based on law of conservation of energy. It is based on law of conservation of energy. Now how to apply? I say first of all we have to select one loop, and I am selecting one loop like this. Take care about this. See, one loop A, B, C, D, E, and A. I am taking this closed loop A, B, C, D, E. Okay, this closed loop. Okay, now closed loop. We have to first of all move from A to B on this path, then B to C on this path, then C to D on this path, D to E on this path, and then E to A on this path. Clear? So it is our path. See, our path. That here I have discussed our path. Clear about this? Now we are starting from point A. So first of all you have to write like this. It is VA. It is V. Clear about this? Now move from point A. First of all, it is cell. Yes, we are moving in this direction. So from positive terminal of cell to negative terminal of cell. And yes, we know that when we move from positive terminal of cell to negative terminal of cell, EMF we have to consider negative. What is its EMF? E1. So I have to write here minus E1. Clear about this? Yes, we are starting from point A, so it is VA. We are starting from point A, so it is VA. Then first element is E, cell, having EMF E1. We are moving from positive terminal to negative terminal, so it is minus E. Clear about this? Now there is resistor. Resistance is R1. Current flowing from it is I1. See, I am moving in this direction, but current flowing from this resistor is in this direction, means opposite direction. And yes, when we are moving in opposite direction of current, there is rising potential. What is rising potential? You have to write plus. So yes, here it is plus I1 R1. Clear about this? Okay, so yes, first of all this cell of EMF E1, then resistors, and now we are at a point B, then we have to move on this path B to C, then again it is a cell E2, positive terminal to negative terminal. C. We are moving from positive terminal to negative terminal. So yes, when we move from positive terminal to negative terminal, we have to consider its EMF. We have to consider its EMF negative, means it is minus E. Means it is minus E. Clear about this? Clear about this? Okay, so yes, it is minus E2. Now again resistance R2, current flowing from it is I2. I am moving in this direction, our loop is in this direction. See, our motion is in opposite direction of current. So yes, when we are in opposite direction of current, there is rising potential. So it is plus I2 R. Clear about this? Clear about this? Now next one. Yes. It is again resistance. See, it is again resistance R3. Current flowing from is I3. Now see, here it is. C to D, we are moving in this direction. From this resistance, current I3 is also moving in this direction. Means we are moving in direction of current. We are moving in direction of current. Means there is potential drop. And how to write this potential drop? By minus I3 R3. Clear about this? Minus I3 R3. Clear? Okay. Next one. Yes, I have said. See, I am changing this cell. That it is negative terminal and it is positive terminal. So now next is cell. I am moving in this direction. From negative terminal to positive terminal. See, from negative terminal to positive terminal. Yes, we know when we move from negative terminal to positive terminal, EMF increases. It is plus E. So here its EMF is E3. So I have to write it as plus E3. Clear about this? Okay. Next one is yes, this resistor R4, current flowing from it I4. Yes, again we are moving in direction of current. So yes, potential drop means you have to write minus I4 R4. Clear about this? Then yes, it is cell. From this cell we are moving in this direction from positive terminal towards negative terminal. From a cell, when we move from positive terminal to negative terminal, that is decreasing EMF. So I can write it as minus E4. Yes, it is minus E4. Clear? Last one is yes, here it is resistance R5. Here it is resistance R5. Let current flowing is I5 in this direction. Resistance R5, current I5. We are moving in direction of current. Obviously, there is potential drop I5 R5. Okay, and now we are again at point A. So yes, according to law of conservation of energy, at a point in a circuit, potential remains same. It does not change with time. So is equal to it is A. Means what is addition of such all changes? If I cut this VA and VA, then algebraic sum of potential differences, potential drops from cell resistor is equal to 0. How to write this equation now? You can write this whole equation again. That is minus E1 plus I1 R1 minus E2 plus I2 R2 minus I3 R3 plus E3 minus I4 R4, then minus E4, then minus I5 R5 is equal to 0. Means changes in potential across cell resistor across each element is equal to 0. Changes in potential, algebraic sum of changes in potential across cells and resistors, it is 0. Clear? And yes, it is Kirchhoff's second law. It is Kirchhoff's second law. Kirchhoff's voltage law. Clear about this? So yes, it is all about Kirchhoff's voltage law. Yes, in your textbook you are given, in your NCERT textbook you are given only statement. But one of the important thing is these 4 figures. You have to remember this sign convention, when EMF positive, when EMF negative, because you have to solve questions based on this. Yes, you have to solve questions based on this. There are most IMP illustration and exercise question that you have to find. In last board examination from current electricity, one question was asked for 3 marks for this from this Kirchhoff's law. Okay, so yes, it is one of the important topic. Again, if you have to repeat your video, then repeat it. But take care about this sign convention. Okay, when to take positive, when to take negative. Clear about this? Right now. Okay, students. Now we will see one question. Yes, it is one extra question. But yes, it will help to understand Kirchhoff's first rule and second rule. Okay, yes, it is also a question from old textbook. But yes, again, it is one question to understand more about Kirchhoff's first rule and second rule. You are given a circuit. Yes, a circuit. Okay, cell, its internal resistance, cell, its internal resistance, cell, its internal resistance, cell, its internal resistance. And yes, it is one external resistance. A, B, C, D are given points. Clear about this? Your question is you have to find potential difference between B and B. Now see, how to find potential difference between 2 points? Between them you are given 2 ohm resistance. Potential difference means V, and V is equal to IR. And we know Just we have to find what is current flowing from this B. What is current flowing from this B? Okay. Now, current flowing, sir, where to flow current? There are given 4 batteries. Okay. So current is not given. Then how to assume current find? Okay. We have to assume current. We have to assume current. See, it is one of the most important thing to apply Kirchhoff's rule, that you will be not given current, you will be not given direction of current. You have to assume. Yes, in this case, you are given 4 cells. 2 volt, 1 volt, 3 volt and 1 volt. What I am doing? Where is cell having maximum largest EMF? It is 3 volt. So I am assuming, remember, I am assuming that current flowing from positive terminal of this 3 volt cell is I in this direction. Yes, current is flowing from positive terminal of this 3V cell. Current is flowing I. Yes, current is flowing. Here it is I. Current is flowing. Yes, it is only one single path. So yes, current remains in single path. Now from this point B, there are 2 branches. Yes, there are 2 branches. So if I say current flowing from this branch is I1, current flowing from this branch is I1, then according to Kirchhoff's first rule, what is current flowing from this branch? It is I minus I1. Clear about this? Total current from this point, it is I. At point B, it is divided into branch. Let current flowing from this is I1. So current in this branch is I minus I1. Clear? Current flowing is I minus I1. Same part. Current flowing is I minus I1. Yes or no? Yes, it is same part. I minus I1. Now at point D, what happens? See, from here there is current I1. From here it is current I minus I1. So yes, they two are entering. Take the algebraic sum. I minus I1 plus I1. So what is resultant? It is I. So yes, current entering in negative terminal of this cell is I. Is I. Yes. If current leaving from positive terminal is I, we move on path, we move in circuit, and if current entering in negative terminal is also I, then you are right. Then you are right in this current distribution. Okay, so first of all, to apply Kirchhoff's law, you have to take current distribution. Okay, again, current flowing from positive terminal of 3 volt cell, I, same path, I. From point B it is divided, that here it is I1, then in this branch it is I minus I1. I minus I1, I minus I1, here it is I1. So at this point they will meet, take the algebraic sum, this side it is I. Clear about this? I. So current leaving this cell is I, current entering this cell is also I. Clear about this? Clear about this? Okay. So yes, our current distribution. So yes, you have to write one statement. Okay. Till that. Current distribution is yes as shown in figure. Current distribution is as shown in figure. Clear about this? Okay. Now we have to find I1. What is our target? We have to find I1. But to find I1, we have to find I also. Means we have to find 2 current, I and I1. Now how to find? See, we will take one close loop. We will take one closed loop. So take closed loop. Take closed loop. Which closed loop? See, first of all, I am taking this closed loop. D, C, B, D. D, C, B, D. Hello students. You can take any loop in any direction. Again, you can take any loop in any direction. Okay, first of all, I am taking this loop. D, C, B, D. Starting from point D, then how to write? VD. Okay, then I am moving in this direction. First, there is resistor. 3 ohm. Current flowing from is I. And see, we are moving in this direction. Yes, from D to C means we are moving in direction of current. Then how to write? Yes, it is minus 3i. Clear about this? Yes, we are moving in this direction. See, we are moving in this direction. Okay, so yes, we are moving in direction of current, so it is minus 3i. Clear? Now, next element is cell. We are moving from negative terminal to positive terminal, and yes, we know that when we move from negative terminal to positive terminal, we have to consider EMF positive. Then yes, it is plus 3. It is plus 3. Clear about this? Then yes, again resistance 1 ohm. Current flowing from is I, and yes, we are moving in this direction. We are moving in this direction. Okay, so we are moving in direction of current. So yes, it is minus 1 into I, means yes, it is I. Clear about this? Next is cell. We are moving in this direction from positive terminal of cell to negative terminal of cell. 1 volt. Yes, you have to consider negative, means it is minus 1. Means it is minus 1. Take care when you write I and 1. Take care when you write I and 1. Okay. Now from point B, we have to move to this point. We have to move to this point. Okay. On this path, there is one resistor, 2 ohm. Its current flowing from is I1. And yes, we are moving in this direction. So we are moving in direction of current. Resistance 2 ohm, current I1. So yes, it is minus 2I1. And again, we reach to point D. Then according to law of conservation, is equal to V. Clear about this? Repeat. See. Starting from point D, VD. 3I in direction, minus 3I. Cell, negative terminal to positive terminal, plus 3. Resistance in direction, minus I. Cell, positive terminal to negative terminal, minus 1. Resistor in direction, minus 2I1. At point D again is equal to VD. VD cut. Okay, then how to simplify this? See, minus 3I and minus I means it will be minus 4I. Minus 3I minus I means it is minus 4I. Now this I1, you see, it is minus 2I1. Clear? So yes, now it is 3 and 1. 3 and 1 means it is plus 2 is equal to 0. Clear about this? So yes, I can write this equation as 4I plus 2I1 is equal to 2. Let it is equation number 1. Let it is equation number 1. Clear about this? Clear about this? Now we have to take another loop. Now we have to take another loop. Which loop we will consider? See, first of all we have considered one loop, D, C, B, D. Now we will consider this loop A, B, D, A. Okay, now take loop A, B, D. Take loop A, B, D. Now starting from point A, so yes, you have to write it as A, B, A. Starting from point A, so yes, you have to write A. Okay, now A to B, we are moving A to B. So first of all, it is cell. We are now moving in this direction. Okay, we are now moving in this direction. A to B in this direction. Okay, so yes, first is cell. We are moving from positive terminal to negative terminal, so its EMF is negative, so it is minus 2. Then it is resistance 2 ohm. Current flowing from is I minus I1. We are moving in opposite direction of current. We are moving in opposite direction of current. So yes, we have to take plus sign and take care when you write it is plus 2I minus I1. Clear about this? Again, resistance is 2. Current flowing from it is I minus I1. We are moving in opposite direction, so plus sign. Okay, now from point B, yes, we are moving in this direction, and you know about this. Okay, yes, it is minus 2I1. Resistance 2 ohm, current I1, we are moving in same direction. Clear? Now from D2 again we have to move towards A. Resistance 1 ohm, current I minus I1, and yes, we are moving in this direction. So we are moving in opposite direction of current. So we have to take plus. We have to take plus. Okay, plus I minus I1. Clear about this? Then cell. Negative terminal to positive terminal, 1 volt, we have to consider plus 1. Again at point A, so just change this. Clear? Okay, repeat. Point A, VA, positive to terminal, minus 2, current in opposite direction, plus 2I minus I1, minus 2I1 plus I minus I1 plus 1 is equal to VA. Clear about this? Now this VA cut, this VA. Now simplify this thing. See, minus 2 plus 2I, minus 2 plus 2I, minus 2I1, minus 2I1, minus 2I1, this one, okay, then plus I, minus I1, minus I1, and plus 1 is equal to 0. Now, first of all, we will write terms having I. It is first term having I, it is another term having I, so 2I plus I means it is 3I, okay, means it is 3I. Now terms having I1, it is I1, it is also I1, and yes, it is I1, minus 2I1, minus 2I1, minus I1, means it is minus 5I. Clear about this? Okay, then about numbers, it is minus 2 and plus 1. Minus 2 plus 1 means it is minus 1 is equal minus 1 is equal to it is 0. Clear? So yes, you can write 3I minus 5I1 is equal to 1. Equation number 4. Yes, physics over. Now it is maths. Physics over, now it is maths. 4I plus 2I1 is equal to 2. 3I minus 5I1 is equal to 1. You have to find value of I and I1. You have to find value of I and I1. How to find? Yes, you know already how to find. Okay, see here, take care what we have to find. Our target is we have to find potential difference between B and D. Potential difference between B and D. So I want to find I1. I want to find I1. Then if I eliminate I will get directly value of I1. How to eliminate I? Here. What is coefficient of I? It is 4. Here coefficient of I is 3. Here coefficient of I is 3. If you want to eliminate I, what to do? Multiply this equation by 3. Multiply this equation by 4. Yes or no? And subtract them. Okay, see, we will do this. Multiply equation number 1 with 3. Okay, multiply equation number with 3. Equation number with 3. Then what you will get? Yes, you will get 4 into 3, 12I. 3 into 2, 6I1. 3 into 2, here is 6. Clear about this? Now, multiply this equation number 2 with 4. With 4. Okay, equation number 2 with 4. Clear about this? Okay, so yes, 4 into 3I, it is 12. It is 12. 4 into 5 means it is 20. So yes, it is minus 20I1. It is minus 20I1. Clear about this? Clear about this? And yes, if you multiply this one by 4, then here is equal to it is 4. Here is equal to it is 4. Okay? Okay, so now take that subtraction because we want to eliminate I. We want to eliminate I. Okay, then if you take subtraction, it is minus, this minus will become positive, and yes, here it is minus. 12I minus 12I, it will become 0. Okay, 6 plus 20 means it will be 26I1 is equal to 6 minus 4, yes, it is 2. Then what is value of I1? I1 is equal to, it is 2 upon 26, means I can write I1 is equal to 1 upon 13 ampere. It is 1 upon 13 ampere. Clear about this? I1 is equal to 1 upon 13 ampere. Yes, it is value of I1. Now how to find potential difference between points B and D? Yes, potential difference between B and D. See, current flowing from B and D is I1 and resistance between B and D is 2. So potential difference between B and D, VBD is equal to 2I1 is equal to 2. What is value of I1? It is 13. So yes, it is 2 upon 13 watt. Potential difference between points B and D. It is 2 by 13 watt. Okay, so it is how to use Kirchhoff's rules. Kirchhoff's first rule applied at this junction B. at this junction B, and Kirchhoff's second rule is applied for 2 loop. Okay, see why, if you may ask me one question, say why to take 2 loops. Here you have 2 variables I and I1, so to solve 2 variables, math says that you need minimum 2 equations. So yes, to form minimum 2 equation, we have to take 2 closed loop. You can take any closed loop. Hello again. You can take any closed loop in any direction. Your answer will be same. Don't worry, your answer will be same. Clear about this? So it is one question. It is application of Kirchhoff's rule. Okay.